Good morning and good evening, everyone. All right, so let's proceed in our learning journey. Now, the topic of this today's session is a really interesting and it's one of the advanced topic when it comes to deep learning, guys. So this topic is about a recurrent neural network. And here we use this recurrent neural network to process the sequence data. So as a part of today's session, we'll understand why we can't use the feed-forward neural network, and we'll also see what is recurrent neural network. That's the main concept that we are going to see today, and we'll see what are the disadvantages that we are going to face or the issues that we are going to face if I'm using this recurrent neural network. And we'll look at the concept of vanishing and exploding gradients, and we'll see how we can overcome these challenges with the help of LSTM, that is long short-term memory units. And at the end, we'll look into the notebook where we have made use of this LSTM neural networks to perform image captioning, which is one of the advanced tasks when it comes to deep learning. So the goal of today's session will be to understand at a high level what exactly does this recurrent neural network is going to do, and how is it different from this LSTM network. So that's what we are going to learn today. Now, the question that everyone would get is, why can't I use my feed-forward neural network? So why can't I use this feed-forward neural network, and why should I go for this recurrent neural network or different type of neural network? Because we know that neural networks are very strong in analyzing the data, even though it takes a lot of time to process the data that we have that we have with us. So feed-forward neural network, it cannot be used for all the tasks. So one of the disadvantage when it comes to feed-forward neural network is it is going to look into single instance of the data, or it is going to look into that instance of the data, and it'll be able to make the decision. So an example can be something like this. So let's assume, okay, if my neural network is exposed to some random collection of photographs, and the first photograph it is exposed is not necessarily alter how it classifies the second, which means whenever I'm training my neural network, when the learning is happening, so that learning is not affected by my previous learning. So in the first scenario, if it learns how to identify the elephant, and when it is trying to identify how the dog looks like, it doesn't consider as how the elephant would look like or how does it impact. Okay, so it's just going to see the photograph of the dog. It will not going to lead the neural network to perceive the elephant next. And another example can be something like this. Let's say you have the collection of photograph of your favorite celebrity. Let's assume you have the favorite celebrity. Justin Bieber is your favorite celebrity, and you have the photographs taken by him throughout the day. Now, on the morning he has taken some photographs, and on the evening he has taken some photograph, and on afternoon he has taken some photographs, and you have all his photographs with you. Now, in one of these scenario, so you have a photograph in the morning. Now once you're having the photograph in the morning, okay, so you'll go through his photographs in the morning, and he will have various pictures where he's on his bed or where he's doing the exercise. Now while he's doing the exercise, let's say he's holding in hand or something. Now since it is a morning photograph, and if he's holding something in his hand, you'd expect that okay, he's having a breakfast by holding a plate. The reason because you have browsed his morning photographs, and okay, you expect that okay, he's having breakfast in the morning. So the reason that you were able to say that okay, so he's going to have a breakfast because uh, you have seen his previous photographs, and you were able to say okay, this is what he's doing since it's a morning time. Now what we have done in this example is like to detect or to identify what is the activity that he is doing in this current instance. So I have considered the data from my previous instance as well. Now that benefit is not having when I'm working with feed forward neural network. Okay, so that's the disadvantage that we are going to face. So, but when we take an example, okay, this is another example. So if I take an example of reading a book, so I'm going to understand this concept of reading a book, or I am going to understand the concept that is mentioned in the book on the basis of the previous things that I have read in that book, or it could be from a previous understanding as well. So it will not be like, okay, I'll not be learning one word at a second. So I'll be learning and on the basis of what I've seen earlier. So I'll use that learning, and when I look into the new data or the new word, I'm going to connect everything to understand as what exactly is being conveyed over there. Now, if I want to represent it in a mathematical way, my learning at the teeth instance, okay? So if I want to say, okay, I'm going to learn what is present in the teeth instance, then I'm going to use the learnings that I had till t minus 1th instance. Okay, so this output that I'm going to get at teeth instance, it is going to depend on all my previous steps instance, that is t minus 1, t minus 2, t minus 3 up to t minus n steps. So that's how my in case of this recurrent neural network would work. Now this is a scenario where we are talking about feed forward neural network itself, so where they're saying it as it's just a one-to-one relationship. Okay, so how can we overcome this challenge? Now the way that we can overcome this challenge is having a neural network structure that would look like this. So in this case of like recurrent neural network, the neural network, if you look into this, my output of my neural network is depend on my current step. It is also depend on what is present in my previous step. Okay, so that is how my neural network, that is recurrent neural network, would work. Now to explain it simply, let me give one more example. Let's assume you want to understand something, okay, or you want to uh, analyze something. Okay, so let's say you have a friend, and your friend one is in USA, and you have another friend who is in India. Okay, now while speaking to your friend in USA, so he conveyed to you in something. So he just conveyed a simple sentence. He mentioned as Rama went to forest. So this is the information that your friend conveyed. Now you want to convey the whatever the information that you have received from your friend in USA to your friend who is in India. And this person in India, he doesn't understand, let's assume, English language, and he wants this information to be conveyed in Hindi language. Okay, so Rama, uh, I'll just say, I'll just tell in Kannada. Okay, Rama Kadige Hodanu. Okay, so it's just saying it as, okay, I'm just converting into a different regional language. This, whatever the information that I've heard in English language, I'm converting it into my regional language to convey the same thing. Now, what I have done over here is, first, I, I understood what is being conveyed over here when my friend conveyed this information to me. Okay, now to convey this information to me, so when this information was conveyed to me, so I analyzed, okay, so this is the information that is being conveyed. Now, since this information is being conveyed, what are the important things that I need to remember? So here it says Rama went to forest. Now, if I want to convert the same thing, first I'll have to understand uh, the important things. So I'll have to encode this. And once I encode and get the information that is present in this given data, I'll have to do the decoding. Now, if I want to do such things, my feed-forward neural network is not going to let me do it. The reason because when I'm getting this data, like when I'm building this information, which says as Rama went to forest and trying to build a translation or a machine translation like application, it is just going to learn my one-to-one relationship. But here in this scenario, I want to understand this entire text as a whole. So I want to understand what this Rama is doing, and I like what exactly is being conveyed over here. Then I'll have to understand everything over here, and then I have to translate it to a different language. Now to enable this, so what we actually do is we make use of this recurrent neural network, and the way it is different from this normal neural network is, I'll write like this: Rama went to forest. So this is the information or the input that I have for my neural network. Now for this neural network, the way I'll be processing is, okay, first I'll get the information about Rama. And once I get this information about Rama, I'm going to send it to my neural network. So from the Rama, let's assume I'm converting into an, like I'm extracting what is being conveyed. Now here in the first information, I'm understanding, okay, I'm talking about the person name. So I'll remember, okay, this is the person name that is being conveyed. Next, when I'm sending this new word that is mentioned as went. Now here in this scenario, when I'm processing this information of went, in such scenarios, I'm also understanding as, okay, who is going, or Rama went. Now who is going? So to understand that, I'll understand as who is going from my previous input as well. That is Rama, that is from my previous learning. And then I'll understand as, okay, so Rama is going. So when I say went, so Rama is going. And then when I look into the two, so I'm getting the action word. Okay, so I'm understanding as, okay, I'm talking about Rama only. When I say Rama went to, when I receive the third input, that is third word, and I'm trying to process it, I'll understand as, okay, so this word is also referring the same noun, that is Rama. And when I get the fourth word, that is forest, so even when I'm processing this fourth word, that is forest, which tells us which place this Rama is going, so even I'll be able to remember and I'll be able to link that, okay, I'm still talking about Rama. So this kind of linkage is not available when it comes to feed-forward neural network, because I'll be processing this data as an individual. So when I say Rama, I'll just understand, okay, Rama. When I say went, I'll just understand went. I'll not be able to build the linkage as, okay, Rama went, or when I say to, who is going, or when I say forest, so who, with whom I'm speaking to. So I'll be forgetting everything when I go to the next step. But in case of recurrent neural network, I'll consider my previous input as well, and I'll be processing the data. Okay. So I hope this gave you a high level understanding as what we are trying to say in this diagram. Now here in this diagram, I'm saying it as, okay, I have an input at t minus 1. Okay. Now with my input at t minus 1, I'm sending it to my neural network, and I'm sending it, I'm from this t minus 1, I'm going to generate some output. Okay. I'll say it as, okay, output at t minus 1. Now, whatever the learnings that I had over here from this input of t minus 1, so when I'm processing the input at t, time step t, that is next step, so I'll use the previous learned information as well, along with this new information of t. And as the step proceeds, so with the new data that I'm receiving, along with that, I'm also trying to understand as what are my learnings till that specific step. So that is how the neural network is going to be structured. So while processing the input at my current step, I'll also process it with the help of the output that I have received in my previous step. So let's understand it in a more generic fashion. So here, so in case of recurrent neural network, it's a type of artificial neural network which we use it to recognize the patterns in a sequence of data. Now these sequence of data can be text, genomes, handwriting, spoken word, or like numerical time series, or the data emanating from sensors, stock markets, and government agencies. So to process all these type of data, we can actually make use of this neural network, because it will help us in understanding the patterns that are present in the data. So when I talk about patterns, so we not only have to analyze the input at my current time step, I also have to analyze on the data that we have received, or the what is my learning in the previous step. So that's the benefit of using this sequential learning approach, that is recurrent neural network. So let's look at this example. Suppose our gym chair trainer has made up a schedule for us, and the schedule is very simple. The exercises are repeated every third day. So this is a simple example that we are going to consider to build the intuition on this recurrent neural network. If I'm using a feed-forward neural network, so what I'll be doing to detect as, okay, what should be my exercise for that specific day. So obviously, in order to build this neural network, I'll make use of my features. So the features can be day of the week, month of the year, and the health status. And based on these three inputs, let's assume I'm trying to build a neural network which will help me to determine as what is the exercise that I'm going to do on that specific day, whether it is a shoulder exercise, or whether it's a biceps exercise, or whether it's a cardio exercise. And that is how I'll be writing my neural network. So it's a very simple fashion because I'll be using my features to generate my labels. But when it comes to recurrent neural network, it works in a different fashion. So what we'll be doing in case of recurrent neural network is, I'll see what is the exercise that I've done on my previous day. If I've done shoulders on my previous day, then on the next day, I'll decide, okay, I'm going to do the biceps on the next day. If I worked on biceps on my current day, then I'll be working on cardio on today. So if I worked on cardio on my previous day, then I'm going to work on shoulders on the current day. So as you can clearly see, in order to determine what should be the output at my current time step t, I'm deciding on the basis of my prediction at t minus 1 step. So which is the same way that we'll be understanding any data or any sequential data. So when I'm reading a book, so in order to understand the fourth word, what is being conveyed, I'll also consider as what is the information that is being conveyed in the first three words. So in the same way, this recurrent neural network, the output at time step t is going to be dependent on t minus 1 step. Now this t minus 1 step is dependent on t minus 2 step, and so on. So that is how we'll consider the output in my previous step as well while determining the output of my current state. Now please note, when I say I'm determining on the basis of t minus 1 step, it's not just I'm determining only based on that. I'll also get the input at my current time step t, and I'll get the output from my t minus 1 step, and then I'm going to process the output at my time step t. So we'll take the combination of, that is the combination of my previous output as well as my current step input. And using both, I'll be able to determine the output of this recurrent neural network. So this is how it would look like. So predicted shoulders yesterday and biceps today. So if I've predicted, so it's the same information team. Okay. So the way that we'll be doing is this. So it's just a combination. So in my time step t, so obviously first we'll have to determine as what could be my previous time step, previous output in my previous time step. It is t minus 1. So information from prediction at the time t minus 1. Now with that information, I'll be able to predict what should be my output at my time step t. Now, since I'll be having the output at my time step t, I'll get the new information and I'll be able to generate the new output in my t plus 1 step. So that's how this recurrent neural network would work. So it's just when I determine the prediction, or when I determine this y hat or the output. So when I determine this y hat or the output from this layer, so some part of this information will go through and it will be used as an input as well for the next time step. So that's the core idea behind this recurrent neural network. Okay, so if I want to represent it mathematically, so this is how it would look like. So here in this recurrent neural network, you can clearly see that here I have the data at the step x naught. Okay, so this is the data at x naught. So here I'll give the same example. Let's say at the timestamp x naught. So I'm doing the, let's assume I'm doing the machine translation. Okay, let's assume at the timestamp x naught, I have the input as Rama. Now with this input as Rama, it will have its respective weights. Since it's a neural network, it will have its respective weights. And because of the respective weights, here I'll find my h naught. Now this h naught is given by wi into, sorry, I'll write as h naught here. Okay, so g of h is equal to w naught x naught plus wr into h t minus 1. So here in my time step 0, the WR is equal to WR is blank, so WR is nothing but the output from my previous timestamp. So since I do not have any previous timestamp, so the output will be 0. So W naught X naught plus B naught. Okay, so the bias of that single neuron that we have over here. So this is how the output will be for this H naught. Now here GH is nothing but my activation that I have over here. Okay, now whatever the output that I'll be generating, so I can use that output. And if I want to generate a timestamp level output, let's assume I'm building a machine translation, then the input that I'm going to give is the English one. Then at this timestamp, I'm going to represent it in a different language. Let's assume in a regional language that I want. Okay, next for the next timestamp, so the next word that I have is went. Okay, so let's assume it's a went. Okay, so it says as, okay, Rama went, or let's assume Rama is, or Rama is. Okay, so it says Rama is, and so this new word that I have over here and this timestamp, it is. Now when I'm processing this new data, I'm going to consider the weights for that new instance of the data. Now, while processing this H1, okay, the intermediate output that we have over here for H1, while processing this H1, I'm going to consider this WIXT in this scenario X1, okay, plus the output weights that I have, the weights that I have for my previous output, that is H0, because H1 minus 1 is H0. So if I want to write this equation for H1, I can say that GH, okay, WI, this is a timestamp one, so I'll say W1 X1 plus WR plus WR into H naught, okay, plus BH. Okay, so that is how I'll be finding the intermediate output over here, that is H1. Now if I want to generate some output for this timestamp, so here it says is, so I may like to represent it, maybe I'll say it as new, so to represent in a different language. And I might have a new word in this timestamp, let's say forest. Okay, so I might have a word as forest. Now when I'm processing this information of forest, I'll consider the weight for this timestamp, and along with that I'll also consider this WRH1 as well. Now what this H1 is dependent on my previous word, that is, and this H1 is also dependent on H0, which is nothing but Rama. So as you can clearly see that the output at my each timestamp is dependent on my previous timestamp output as well. So that's the difference between my feed-forward neural network with this recurrent neural network. Okay, so this BY or BH, so these BY or BH, these are nothing but the bias in neurons. So these are nothing but the bias in the neurons. So they are not the error terms, so they are the bias terms. Bias is nothing but like the term that we add for the linear term, which will help them to learn the data representation or as much representation that it can from the given data. Now put it simply, so it will enable my model to consider every data point in the plane. Now to give you an intuition, from our high school, we know that the equation of line is given by y is equal to mx plus c. So this is the equation that we know, which represents my straight line. Now, if I remove C, okay, I would still get a straight line, but this straight line will only pass through my origin. For every value of M, it can only pass through the origin. Now, if I have any data points, which is in this fashion, so obviously my data point or by this line that I want to join, so it will not pass through my origin. So in such scenarios, I'll have to make sure that I'll be writing a line which passes through all the data points and is not passing through the origin. In such scenarios, we require the C representation. So this C term in this example that I mentioned, so this is called as bias in machine learning. So bias in machine learning or machine learning model. So we also have another term that's called as bias, and we refer that bias term to say, okay, whether it is biased towards any data. So here, when I talk about bias over here, this bias helps my neural network to learn the data representations in an efficient manner. So it is like a coefficient. Yes, you can think of it as a coefficient, uh, but this coefficient will be predicted. So it's a predictable value which will be predicted during the training purpose. So during the training process, I'll be learning this constant. Okay, now how does the training of this recurrent neural network would occur? So when we are training this recurrent neural network, now this recurrent neural network, it also uses the backpropagation algorithm which is being used by feedforward neural network. But the difference is it uses the concept that's known as backpropagation through timestamp. The reason because we know that at every timestamp, the output of my current timestamp is dependent on my previous timestamp as well. Hence, we perform this backpropagation through timestamps. And when we are performing this activity of backpropagation through timestamp, two common issues that we are going to face when we are working with recurrent neural network, that is vanishing gradient problem and explosion gradient or exploding gradient. Now, when I talk about vanishing gradient problem, it's like as the training proceeds. So when I'm updating the parameters, models parameter, so the parameters in my lower level, so it won't be updated. The reason because the but gradients become very smaller and smaller. And when it comes to exploding problem, so when I have a very large gradient, so as I go deeper and deeper, the gradient value become very high, and I may not be able to learn from the data in an efficient manner, and I may not be able to converge as well. So these are the two common issues that we are going to face when we are training this recurrent neural network. So the next two slides talks about as intuition behind the same and the how does it look like. So in case of backpropagation, the way that we'll be updating our models parameter is we'll say, okay, W at my current timestamp. So if I want to update it, I'll say it as W is equal to W plus delta W. Now this delta W is nothing but partial derivative of my error term with respect to that parameter. Okay, so if I'm using this error term as a squared error loss, it is nothing but actual output minus model output squared. So that's going to give me this error. Now, if my gradient is very small, then in each timestamp, then the updates that would happen on each of these parameters will be very small. And as it goes deeper and deeper in the recurrent neural network, some parameters might not be updated as well. Now that is called as vanishing gradient problem. The opposite will happen as well. So when the gradient becomes very high, in such scenarios, it is going to fluctuate my values of W, and it would also result in not uh, not reaching the optimal values. So that is a problem of exploding gradient. So in order to overcome these challenges, we make use of a specific type of neural network that is called as LSTM. But before we understand about this concept of LSTM, let's see what are the other ways that we can overcome these challenges. So one way that I can overcome these challenges, especially when it comes to exploding gradient, is I can make use of truncated back propagation through time operation. So instead of starting the back propagation at the last timestamp, I can choose a very smaller timestamp like 10. So in such scenarios, obviously I'll be losing the temporal context after 10 timestamps, but that's okay for me. Or I can make use of clip gradients at the threshold. So I can set a threshold, and if the gradient that I'm getting is lesser than the threshold, then I'll be using a minimum set threshold. Or the another way is I can make use of RMS prop, which is going to adjust my learning rate. So these are the ways that I can minimize this exploding gradient problems. And when it comes to vanishing gradients problem, I can make use of ReLU activation function or use the similar algorithm, the learning algorithm that is RMS prop as well, or using the neural network, which is called as LSTM and GRU. So these LSTM and GRUs are the different network architectures which has been specially designed to combat this problem of vanishing dead ends. Okay, so let's have a quick introduction to what are these LSTM, that is long short-term memory networks. So this LSTM, that is long short-term memory networks, it's actually called as LSTMs, are a special kind of recurrent neural network, which means it is able to work with sequential data. And the best part is they are capable of learning long-term dependencies. So when I say long-term dependencies, so it is able to understand it is able to process the information at my timestamp t. Along with that, it can learn better or it can remember better compared to my normal neural network. That means it can remember better from my previous network, previous layers as well, compared to my classical recurrent neural network. Okay, so that's the benefit of this LSTM. So this is how the structure of my LSTM would look like. Now this LSTM has many components. So I'll just give you an overview of these components. So first, we are going to have something that's called as forget layer. Now this forget gate layer, it's going to decide as what are the things that I have to forget from this timestamp. So if I'm processing the information in my current timestamp, that will be the information xt, and I'm using my output from my previous timestamp ht minus 1. So what is the information that I do not want right now for my current timestamp? Suppose working uh, if I'm working on the task of machine translation and I have a text that says as Rama went to garden. Okay, let's assume in my timestamp xt, uh, or timestamp, this is x0, x1, x2 and x3. So when I'm processing this information of garden, okay, so in my previous timestamp, so I have the information about went and to. So obviously I can analyze that. Okay, so I'm talking about Rama. So from my previous output which I'm getting, or the previous information that I'm getting, I can ignore this word to. I can forget this. I can only keep this word of went for my current processing. So that's the high level that I can say what happens in my forget layer. So this forget layer is going to identify the information that are not required, and it will be thrown away from my cell state. So that's what happens in my forget layer. So the first layer that we have seen is my forget layer. It's going to help me to forget the things which are not required to me. And after this forget layer, we have the second step. Now here in my second step is going to determine as what is the new information that I'm going to read for, or I'm going to need from this timestamp. So here I'll get the same information of xt. I'll also get the information from my previous output. So I'll be deciding as, okay, what is the information that I'm going to require from this output or from this layer. Okay, so here we have the information that says as Rama went to garden. So Rama went is my previous information that I'm currently having, and garden is another information. So I'll be deciding as, okay, so from this final output of Rama went garden, what exactly is the information which is important for me? Okay, so what exactly is the information that I need to remember so that I can process it? So that's what is going to happen in case of this second step. And in the third timestamp, we are going to update the, so we'll update the old cell state CT minus 1. That is the information that is flowing from my previous timestamp. Okay, so we'll multiply, and from this previous data that I'm receiving, I'm going to forget it with the help of my learning from my first step 1, and then along with that, whatever the information that I have learned this time, so I'm going to add it together that I've learned in my step 2. So I can see that from previous knowledge, okay, forget unimportant ones and learn new important ones. So this forgetting the unimportant ones is being learned, is being done in a first layer, and adding the or learning the new important ones is being taken care in my second part. Okay. Now this will be stored as a cell state. Now this cell state will be used for my long-term learning, or for this long remembrance, or for this CT will contain the overall information of this neural network. Now, apart from this, we also have one more information, which is the short-term memory. Now, this short-term memory is going to decide as what is the output of this current state. So in case of the short-term memory, so we are going to make use of tanh activation layer, and we'll also make use of the sigmoid layer, and to decide as, okay, from this output of my current state, what is the information that I want to give. So that is how this LSTM neural network is going to work. So I'll have my forget gate. I'll also have my like add gate or the information gate, and along with that I'll also have my processing gate for my current layer. So with this intuition, let's look at the code example, which will help us in like which will give you an intuition of the importance of this recurrent neural network, more specifically the LSTM. Okay, so here we'll look at this notebook. So this notebook is called as image captioning using LSTM. So the task that we are doing over here is given the set of images. So I have some set of images, and I also have some set of text as well. Now given this text and the images, so I'll give a new input which I have with me, and I'm going to run the prediction, and that prediction is going to tell me as, okay, what is present in the given image. So if you look at it at the end of this notebook, so here I've inserted this new image which I've downloaded from a different data set. So I've downloaded this image and I've uploaded over here and have generated the description. That means I've ran the prediction for my model, and my model is telling me as this image contains a man in a helmet. So it says, caption says, a man in a helmet is riding a bicycle on a dirt track end. Okay, so this is what we have been able to do with the help of this LSTM. So I'll just come up and I'll explain at a high level what is happening over here. So here we are making use of a data set that's called as Flickr 8K dataset, and it contains 8,000 images with 5 different caption annotation. So we'll start by importing the libraries, and here we'll use the VG16 model to work with the image data. And along with that, we'll also make use of Keras pre-processing model, and we'll make use of necessary functions to enable us to work with text data. And we'll make use of NLTK translate blue score to perform the how to measure as how my model is performing. We'll load the data set. So here we are loading the data set from the GitHub repository, and then we'll also download some data images as well. And once we download the image, process the data, we are going to process our text data, and we are going to make sure that it is in the right format which can be used on our neural network. And then as we proceed, so at the end we'll also process our image to make sure that it is going to be applied on my VG16 neural network. And once that is done, these are all the custom functions that has been written over here. And once that is done, we are going to write the data which is going to help us to send the data in a sequential manner. Once the data preparation activity is complete, we are going to train the model. Once the model is trained, we can generate the prediction. Now to generate the prediction, so this is a custom function that we have written to perform the generation of prediction. So to summarize, when it comes to feed-forward neural network, I can only process the data, and once I process that instance data, I'll not be referring the learning from the data when I'm processing the next data, which means I'll be treating each and every instance as a separate one. So I'm sure I'll be remembering the parameters, but I'll not be remembering the context in which that input output is being given. So in order to remember the context, we should be able to process the data in a sequential manner. So to process the data in a sequential manner, we actually make use of this recurrent neural network. Now, in case of recurrent neural network, the output of at my timestamp t is dependent on the output at timestamp t minus 1 along with the input at timestamp t. So that's the intuition behind recurrent neural network. And LSTM model is going to help me to avoid the avoid the issues that we are going to face when you are working with RNN, that is the vanishing gradients problem. So it has various gates to help us to perform selective learn, selective forget, and selective read from the data as well. So that's the advantage when it comes to LSTM. And we have seen this hands-on notebook where you'll be executing at your end, and you can see the output as well. So here, uh, like I just gave an example image and it was able to perform the captioning from its end itself. So I did not specify what is present in the image. So I just gave this as an input and it was able to identify it from its end itself. Okay, now to get to know and to learn more about this TensorFlow, so go to this website of tensorflow.org, click on learn, and here get started with TensorFlow. Click on this learn more. You'll be redirected to the tutorials that are available in the TensorFlow. Okay, and you can start your learning in this TensorFlow over here. Thank you so much, guys. It was amazing interacting with each and every one of you. Thank you for your time. I'll see you next time.